Hello everyone, my name is Yingmeng.Xiao, came from Institute of Mechanicals, Chinese Academy of Science, China. Today my short topic is effect of temperature on fracture property of additively manufactured titanium alloy. The presentation concludes four parts. Completely different from conventional fabrication methods, additive manufacturing is an advanced manufacturing technology. ASTM defines AM as a process of connecting materials from three-dimensional model data to create objects, usually layer by layer rather than subtraction. There are seven types of AM. For metal, the most widely used is powder bed fusion. In our study, we used the selective laser melting process. Titanium alloy is a widely used structural alloy. The current research on AM titanium alloy mainly focuses on the following aspects. The main issue associated with SAM is the structural integrity assessment and the life prediction of related components. In particular, fracture behavior of SAM metals needs to be clearly understood. This is true for titanium alloy, which is the most widely used alloy in the aerospace industry. Research on low temperature resistance of SM titanium alloy is lacking. In this study, fracture toughness of SM titanium alloy using selective laser melting technique at different temperatures were investigated. Now I will introduce the materials and experimental procedure. Table 1 and 2 showed the nominal chemical composition and the process parameters of titanium alloy. Relative density was measured by Archimedes method, and the calculated input energy density is 60.3 joules per cubic millimeters. The SM scanning strategy and the specimen orientations are shown in this figure. Before processing, specimens are lined at 800 Celsius for 4 hours. Tensile tests at 4 temperatures and fracture tests at 3 temperatures. For microstructure observation, 2 samples with different orientations were selected, and the horizontal section was named B, and the longitudinal section was named S. The results for different tests were got. Figure A shows prior beta grains appear square with an average length of 90 micron in B plane. Figure B shows a vertical columnar grains which are aligned along the build direction with the smaller grain size in the S plane. Because of the multiple boundaries MPB, the inverse figure of sample B in figure A shows obverse prior beta grain and the basket weave structure. The average aspect ratio of acicular grains is 8.28. The texture strength of B plane and S plane varied by nearly 50%. This indicates that there are more lattices with similar orientations in B plane. The OM and ABSD images for sample B and S show significant anisotropy of SM process. Tensile test results were shown in this figure and table 3. Temperature has a great effect on yield strength and ultimate tensile strength. The strength increases with decreasing temperature. To explain this phenomenon, we observed the fracture surface of tensile specimens and obtained the damper fractions at different temperatures by image analysis software, Image Pro. We can find compared to the 150 Celsius specimen, the damper fraction of the 25 Celsius increases by about 22.9%. About the fracture toughness. With the decrease of temperature, the provisional or critical fracture toughness of specimen is decreasing. In addition, The following figure illustrates that crack deflection occurs mainly with the translamar crack propagation, and a serrated crack propagation path is formed. The fracture surface of specimen were observed by scanning electron microscopy. It was noted that the fracture surface is divided into two regions. In the fatigue pre-crack region 1, cleavage facets, fatigue strips, and a large number of secondary cracks were observed. In the region 2, the fracture surface is roughly and covered with hidden staples. In addition, at the junction of the two regions exhibits large raven. The major defects observed of this alloy are keyholing pool, smooth facets, lack of fission region, and gas pores. These defects are usually crack illustrations reported in many reports. The influence of corrective plastic ruin on fracture pathways at different temperatures were considered. The constitutive relationship used is the Ramberg-Good model. Due to symmetry considerations, only quarter of the specimen is modeled, and the boundary condition and corrective mesh details of the 3D FEM model is shown in this figure. From the following results, we can find that with the decrease of temperature, the maximum of vortices increases and the volume decreases. Finally, we collect the results of experiments and calculations. There were several conclusions about this study which are important for the structural integrator assessment and the NAF prediction of titanium alloy. In addition, it helps us better understand the fracture behaviors of SN components. Thank you for your kind attention. That's all my presentation.